Now, next question which we have is there are 40 bulbs. Okay, there are 40 watt bulbs. How many 40 watt bulbs there are? How many? Can safely be connected in parallel. Okay, suppose there is one 40 watt bulb. Okay, there is another 40 watt bulb. There is another 40. They all are connected in parallel. Okay, and in this way we have connected so many 40 watt bulb in parallel. Okay, so many 40 watt bulb we have connected. Suppose total of bulb which I have connected here is n number of bulb. It n may be 10 bulb or 20 bulb. It may be anything. Okay, n number of bulb through a 5 ampere fuse. What do you know what it means? 5 ampere fuse. Let me explain. Okay, I am assuming I have connected n bulbs. Okay, wait a minute. Now and 220 volt supply. So look, student, all the bulbs have been connected in parallel and they have been connected with a power supply of 220 volt. Okay, so this is, and the net current which is flowing in the circuit is I is 5 ampere. You know, so using this current and this voltage, if I try to calculate the whole resistance, okay, suppose the whole resistance is how much? Suppose the whole resistance, remember the equivalent resistance case. The whole resistance is R total. Okay, suppose R total. And this is our 220 volt. And how much current is flowing through this circuit? 5 ampere. Okay, so this is equivalent case. Now if I apply Ohm's law, V is equal to IR, I will certainly get R is equal to V by I. Okay, and R is equal to V by I gives us 220 divided by 5 means 4.4 ohm. Okay, 4.4 ohm. This is 5. So according to the question, if I try to analyze, the final conclusion is this, that the whole resistance of this combination should be 4.4 ohm. This is final. Why? Because using this current and using this voltage, I calculated the resistance of this combination and which came out 4.4 ohm. So now the total resistance of whole combination should be 4.4 ohm. Now they have asked how many, and I have assumed is n bulb. They have asked how many bulbs you have connected. I have assumed n bulb. So and they all have same resistance. If it has a resistance of x, then it will have x. It will have x. Better I assume R. Okay. So it will have a resistance of R. It will have a resistance of R. It will have a R, and so on R resistance. There are n resistance. Okay, so now one thing, student, look, I know that in parallel combination the total resistance Rp is simply 1 by R1, 1 by R2, 1 by R3. Okay, when there are three resistance, but if there are more resistance it will just go on 1 by R4, so and dot dot dot. Suppose n resistance are there and then 1 by Rn. Now, according to the question, all resistance are equal. They all are equal. Okay, R2 are all are equal. And how much they are? So they all are R. They all are equal to R. So I'll just write R everywhere. Okay, and so on 1 by R. How many times it is? It is n times. Now tell me one thing. If I write x plus x, it gives us 2x. If I write x plus x plus x, it will give us 3x. So the number of times you write x, a number appears here, same way. If I am writing 1 by r plus 1 by r, if x plus x was 2x, then 1 by r plus 1 by r will be 2 into 1 by r. Okay. Similarly, 1 by r plus 1 by r plus 1 by r, it is 3 times. So it will be 3 into 1 by r. If it is 3 times, then it is 3 into 1 by r. If it is 2 times, then it is 2 into 1 by r. Then if it is n times, it will be n into 1 by r. Okay. Now, So this is the total resistance of the combination. Okay, now let me erase it. Now one thing, if 1 by Rp is N into 1 by R, okay, and 40-watt bulb, okay, the bulb has a power of 40 watt, okay, so I'll have to calculate the resistance using that 40 watt. So using this, student, using this, I had calculated this Rp. How much Rp was? Rp was this. Remember, this combination, the resistance of this combination was 4.4. So I'll simply write it as for either 4.4, you write 4.4. This is N and 1 by R. Now I have to calculate this 1 by R. So how to calculate? We have been given that, look, one thing which is worth noticing here is that, okay, wait a minute. Look, we know that in parallel combination, every resistance, either this one or this one or this one, every resistance is getting the same voltage. Okay, every resistance is getting the same voltage. And what is the voltage here? Here voltage is 220. So every resistance is getting here 220 volt, and it has a value R, and it has a power 40. So we know that power is equal to V square by R. Okay, this is one of the formula. Power is also VI. Power is also I square R. So I'll not be using this formula. Why? Because I don't have I, but I have this voltage 220 volt. Because in parallel combination, every resistance get 220 volt. Okay, so this is the fact. So using this, we can calculate R is equal to V square by P, and V is 220 into 220 divided by this 40. This will cancel out, and if I try to cancel this will again be 4.4. Okay, so this is 4.4 into 22. I am not going to calculate it. Why? Because I have to put it simply here. I am going to put it simply here. So R is 4.4 into 22. So I am going to put it here, 4.4 into 22. N into 4.4 into 22. Now you can easily watch. You can easily watch that we have got this equation. Means, okay, let me write it here. 1 by 4.4 is equal to N into 1 by 4.4 into 22. Now from the denominator, this 4.4 will cancel out, and this will be cross multiplied here. So 22 is equal to simply N. So 22 resistance we will have to join this in parallel, so that it can endure 220 volt and 5 ampere current will flow in the circuit. Okay, so this is the answer. I hope you have got it.